Hey guys, my name is Akshay Bahadur. Today I'll be talking about my research project, Indian Sign Language Recognition System, also called as STAR. Before we start, just want to give a brief introduction about myself. So I'm currently working as a senior data scientist at Lowe's. I'm also a Google developer expert in machine learning. I received the most influential young data scientist of the year award in 2019. I was awarded a top Intel Innovator Award in 2019. I've been invited for over 50 sessions and keynotes on machine learning. So these are some of the snippets from the conferences. You can see I've been to a couple of conferences sharing my work, and this research project is an outcome of getting those experience while going out there. So before we start, an important link for everyone. So if you want to follow along or if you want to get some references to the sites, just go to bit.ly/PyData-20 and you will be redirected to my GitHub page, which has this repository. And you can just click on the links or the slides and follow along, or you can even open some issues on the GitHub itself on the repository if you have any questions. So with that in mind, let's start with the project. So let's start with the definition. So the project demonstrates the use of machine learning to develop and standardize an Indian sign language recognition system. So these two terms, develop and standardize, are important for us. We'll discuss about these two terms specifically in some of the later slides. Let's move along. So now we are defining our problem statement. So some of the so I did some research, initial research about around 16 months back about the scope of our project. So what I realized is that 40 million people in India are currently suffering from speech and hearing impairment. 80 kilometers is a different distance between Mumbai and Pune, two major cities in Maharashtra. Uh, these are the places where I work and I live respectively, like my hometown. And within 80 kilometers, the sign language has very significant changes. So let's come up with an ideal solution. So based on my research, the ideal solution had some key features. First, was to standardize ISL, like American Sign Language. So American Sign Language is standardized within the US. So anybody who's a deaf and mute who's a deaf and mute person can travel from and to and from different states without having to learn a different version of sign language. Also, can we leverage AI to accurately predict minute changes in signs and symbols? So this is where AI or machine learning becomes very effective to be able to generalize well to the data at hand. Third is most important for me was to keep the resource intensity to a bare minimum. This will ensure that I could scale my model. I could reach reach out to people who are not living in very posh areas, but they still want to make use of this technology. So I do not use any internet or heavy GPUs or any external hardware uh, because I wanted to keep this accessible to most of the people. So the methodology that I followed was to actually categorize the problem into three different subcategories. So if I knew about the hand movement, if I knew about the facial expressions, and if I had some idea about the pose of the person, I could come up with an interpolation. So this was my thought process. And what I did was I divided my work into different phases. So this comes the development part, and this is where I actually went to an NGO. I studied sign language for about 6 to 7 months, and this is a video from that NGO. So these are some of the students from the NGO who have been a student, as well as they are also now learning. I mean, they're part of the sign language community in India, and these guys really helped me and my friends to know about sign language and what are the problems that they have faced and how can us as a community improve their standard of living. So you can find the whole video on my YouTube channel. So I divided the work in phases as already mentioned. So phase zero was only working with hand gestures. So as you can see, I'm only working with hand gestures. So these are different digits and different alphabets. So these are different interpretations for different alphabets, and the results were very promising. So I used image processing and integrated that with machine learning. to come up with an application that could that could interpret these sign languages in runtime. As you can see, I'm only working with alphabets and digits. Therefore, the model is not very complex. Now, the phase one was as already discussed, facial expressions were very important for us. So I came up with this algorithm of using sign language of using hand gestures as well as facial key points to make our model more robust, and the results were really promising. So as you can see that I'm only working with a skeleton image. So on the right, you see my facial key point tracking mechanism as well as my hand gesture mechanism. So even though there are a lot of background noise in the frame, I'm only working with just some key aspects. And this made my model to be lightweight and it could even scale to reach millions of people. Then I came up with another technique. This is integrating full text to speech. Uh, so this would make sure that I could reach out to more people. So you can check out the whole video about this process on my YouTube channel. And one of the very interesting things that happened was I was invited by Google to visit the headquarters in California, and I got a chance to present my work to the TensorFlow team itself. Here's a small snippet of it. So you can have a look at the whole video if you're really interested. It's on my YouTube channel, and it's around 7 to 8 minutes where I got a chance to just give an elevator pitch of my project, and I also got good feedback from the community as well as the TensorFlow team on how I could improve this on this application. So with that, I would like to end my session. If you have any questions, feel free to reach out to me. If you have any feedback for my presentation or for my application, if you feel that I could improve certain aspects, feel free to do that. Feel free to reach out to me at akshaybahadurcom, where you can just drop your comments or some references. I will have a look at that. I will definitely get back to you as quickly as possible. So once again, thank you so much for listening to me. My name is Akshay Bahadur. You can follow me on Twitter at Akshay Bahadur. You can even follow me on my personal website, akshaybahadurcom. And if you want to get all the information about this session, go to bit.ly/PyData-20. This is where I have all the slides and all the references. So with this, I would like to thank each and every one of you for listening to me. I hope you guys are keeping safe, and I'm also hoping that we meet soon in person. Take care of yourself. Bye.